Hi everyone, welcome to the channel. I hope you're all having a wonderful day. Today we'll be looking at the problem number of islands. If you are interested in data structure and algorithm questions, please like and subscribe and follow me on social media for updates. Since today's problem is on islands, question of the day for this video is, what is one island that you want to travel to? Please comment below with by typing QOTD : and the answer to this question. Without further ado, let us learn something epic. Alright, so we have this problem, number of islands. So it says here we're given a 2D grid map of ones and zeros, and we count the number of islands. An island is surrounded by water and is formed by connecting adjacent lands horizontally or vertically. You may assume all four edges of the grid are all surrounded by water. So you see here, there's one island, all of these ones are connected. And then for here, we see there are two islands. So this looks like a problem where we can solve with DFS. If we apply DFS here, all of these ones will be explored, and we can mark them as false as we traverse. That way, after traversing this point, we will explore this island, increment the counter, +1, and then when we go to the other points, there would be no incrementation. So we would get the correct answer. Seeing this problem, if we continue our method where we iterate all points in the matrix and applying DFS to each element, we see apply DFS here. These four will be explored, and so all of these points, when we iterate to them, they will not increment the counter for island. So here the count will become 1, and then we reach this point, the count will become 2, number of islands, and then once we reach here, the count will be 3. Let's reset the code. So writing our main idea, we iterate the elements of the matrix, apply DFS on each of the elements. And we only apply DFS if that element has not been traversed. And you have to make sure it's a 1 because we're counting the number of islands. So if we see water and we haven't traversed it, we don't actually want to run DFS. Now we see that our algorithm iterates the number of elements in the matrix. So let's say the matrix has m rows and n columns. Then we iterate through each of the elements. So that means it's m times n. And when we apply DFS, we are traveling to each of the elements at most once, because we only, the worst case is 1, because the worst case is the entire matrix is 1, so our DFS will traverse to each of those elements. And then because we're also iterating all the elements of the matrix, on the iteration we'll travel to each of the elements. So that means the worst case in this algorithm is we travel to each of the elements twice. And constants are ignored in big O. So that means our runtime is m times n. And the space complexity is constant because we are doing this in place. So to iterate the elements of the matrix, we first get the rows and the columns. So the rows we will get with length of grid. Well, let's see, grid is a list of lists. if we get the length of it right, length of grid is the number of rows, and then if we do grid of 0, we get the first row, and then it tells us how many columns there are. So now we can iterate. So now we get each element, and we check if it equals 1. Now, I don't know if it's equal to a string or a number, so that's a thing to check. Might be string. We could test one of our cases like that. Then we apply DFS. And we increment island count. So above, we need to keep track of the island. We need to initiate. The count for the island starts with 0. And after this, return island count. So now we have to implement DFS. We'll feed in the grid and the elements we want to perform DFS on. First, we fill a queue with the element. So long as the queue is not equal to 0, we will keep performing DFS. And so first thing is current equals queue pop. Once we pop that element, we get the neighbors. So we have to get left neighbor, right neighbor, top neighbor, bottom neighbor. And also, once you take out this element, you make that element equal to 0 because we have traversed to that location. So cur 0, cur 1, those are the x and y coordinates. So left neighbor, we have to check if it's in bounds. So if we check the left, it would be, well, let's make this notation a little bit easier. Our left neighbor, it would be x minus 1 is greater than equal to 0. Otherwise, we'll be indexing out of bounds. And you only do this if that element is a 1. So if that is the case, then we put that element onto the queue. The other case is if the right, so we'll check x plus 1 less than equal to, so let's say if the length of a matrix is 3 elements, then it must be less than 3 minus 1. So column minus 1. I see. Looks like column hasn't been defined yet. So I should probably put that on top. Suppose swap, well, I can't swap it because DFS, this function has to be after. Well, no matter, I could define this before. This way DFS has access to row and column. Right, so it's not actually cur, it's supposed to be grid. You look in the grid to see. if the element is equal to 1. Now, the last thing is to check top. So if top, that is y plus 1 less than or equal to 0. Greater than or equal to 0. Because you can't get a row of negatives. And we'll look into the grid. Make sure it's equal to 1. Then we check the bottom. That's y. Right, so this is actually y minus 1, because if you check the top neighbor, if you're on 1, 0, you look at 0, 0. That's your top neighbor. Now the bottom neighbor, it's y plus 1. This one we want it less than or equal to rows. Rows minus 1, yes. Same concept as columns. All right, and that's our DFS, but we want to return grid because now all the elements have been traversed and we want to feed it to here. So we could reuse the grid and we'll have all the elements that have already been traversed. So now we can look through the code, make sure everything is good. Probably run some custom tests before submitting. So you see first we establish the rows and the column. We take that from grid, length of grid. If it has 3 rows, we'll get 3. And then column will get the first row, and then that yields how many columns there are. We'll skip DFS now because the code runs the island count. It starts with 0, then we iterate through rows and columns, so we get 0, 1, 2, if we have 3 rows. And then we check if that current element is a 1. Yes, and then if it's a 1, it means we apply DFS. So we apply DFS, and then we get the results, and then we increment island count plus equals 1. Then we return the island. So now we check our DFS to make sure it's doing what it's supposed to. First thing we do is we have a queue, and we initiate I and J as the first element. As long as the queue is not 0, it's not empty, we will continue to run DFS. So we take the first element, then we get the x and y coordinates, cur 0, cur 1. And then we look at the grid and we make that equal to 0. So I guess we could keep literal and stay consistent if it turns out to be strings. Assuming they are, but we'll find out sooner rather than later. And so we check the left neighbor, that's x minus 1. We make sure it's greater than or equal to 0 because we don't want it to be out of bounds on the left side. And then we check the grid, x minus 1, y, see if it's 1. If it is, then we append this element, so x minus 1, match, y, match, that looks good. Then we check the right neighbor, it's x plus 1, and it needs to be less than or equal to column minus 1. And then x plus 1, y, so that matches, this matches, good, good. Top neighbor, y minus 1, and right here I wrote y plus 1, so that's incorrect. So it should be y minus 1 equals 1. And then we append x, y minus 1, that looks good. And then bottom neighbor plus 1 less than or equal to rows minus 1. Yes, because that, yeah. And then y plus 1x. Okay, now we can check our example to make sure it's good. So we have this sample here. We can put it here. Mainly we just need to see DFS. We know that it will go through. So we see we see we iterate here. So we get 0, 0. That's our first call to DFS. We see that it is a 1. Then 0, 0 gets placed here. it gets popped. Then we have an element 0, 0, then we make it 0. Bam. And then it checks the left neighbor, there's none. And then it checks the right neighbor, okay, it sees that. And then it puts it on the queue, puts this one on the queue. And then top neighbor it doesn't have, and then bottom neighbor, so it puts these two on the queue. Put a started note that is on the queue. Then once we have those, we'll pop this one from the queue. And then we'll put its neighbors on the queue. And so they'll become 0. And so we see in our example, if we continue this trend, this will become 0, this will become 0. And each time they'll be putting their neighbors on. So that looks good. Let's try it with a custom test case. This looks like the first one, so let's see what happens here. So we get a compile error, all right, 39. If grid ij equals, oh, I see, I forgot to do the colon. So let's be a little bit more, let me be a little bit more careful. So it's like our while loop is good with the colon, if statement good, if statement good, if statement good. All the colons are good, so it went to 39 before, so it could error after. It didn't call DFS yet, but I just checked that. Island count, okay, let's see, this is good. Let's get a runtime error. Int object not iterable. 37. Right. So we want to iterate the numbers, so we actually have to use range. Alright, so this one we seem to get the expected answer. Let's do one more test. Try the other example. So let's see. So it's 1, 1, 2 rows of 1, 1. Okay, and 1 in the middle, and then 2 rows, 1, 1 at the end. Okay. Alright, so let's see. This one works. 2 rows, 1, 1, then 1 in the middle. And then 1, 1 at the end. Runtime error. List of index out of range. So we have that at line 22. X plus 1 less than or equal to column minus 1. Wait, X is row. Y is column, so I think that's the problem. Rows, and then this one's supposed to be column. Wait. Oh, yeah, that is. Because if you're changing the X coordinate, it's left and right. Wait, what? Left and right, so that should be checking columns. And then if it's plus minus in the Y. Wait. So the left neighbor, if I change X, oh, this is top and down. So this one is row. And this is top. X minus 1, that's bottom neighbor. Top neighbor. This is left. Right. And when you do left, right, that's column. So let's see, that's correction. So it looks like 3, okay. But just to be a little bit more certain, let's see if it covers the other example. 4 1s and 2 1s, okay. All right, looks good. Let's try to submit and see what happens. Runtime here. Line 8, list index out of range. Okay, I think what's happening is it's possible that we have an empty matrix. So let's see if that's the case. Yeah, it looks like it should be the empty. All right, great, accepted. Well, hope you guys were able to learn something from this experience. Also, you got to see how to correct last minute issues. Definitely, this has been useful for me, helped me realize a couple things I overlooked. And during an actual interview, it sheds light on what areas I need to work on, like checking the if loops, making sure the syntax is good. I think also I should have ran through an example actually using the rows and columns. That would have prevented me from making a mistake of bottom neighbor, top neighbor, and with confusing it with left neighbor and right neighbor. So yeah, that's something I think I should do to improve in the future. But yeah, if you guys have any other feedback, definitely put in the comments below. If you guys learned something and had fun, please like and subscribe and share with anyone else that you think will find this useful. Yeah, and with that, thank you so much for your time and enjoy the rest of your day.